Let's design a very simple three-phase generator circuit. Basically, I needed a variable frequency signal with variable voltage option. I need 400 Hz oscillator. Its frequency I can adjust from 350 to 450 Hz as a test pattern generator. For that purpose, I will use a simple CD4035 4-stage parallel in parallel out shift register. We will use another IC CD4049. It will provide three-phase signal with 120-degree phase shift. Each phase can be split into high and low signals. For that purpose, I will use IPM, Intelligent Power Module, to utilize these signals, and I will provide DC rail on IPM. So I will take variable frequency, variable voltage signal. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel and you have not subscribed until now, you can subscribe it. MC14035 HEF4035 pin number 16 VDD. I will use 12 volt. Pin number 8 ground VSS. Pin number 6 clock signal. Here is pin number 16 positive supply, and same time we will connect pin number 2 to VDD. Here is positive rail and here negative rail. Pin number 8 grounded. We will connect pin number 5, that is reset pin, pin number 12 and pin number 10. 8, 5, 12, 10 will be grounded. 5 grounded. Pin number 10 grounded. Pin number 12. 9, 10, 11, 12. 12 also grounded. We will connect jumper between pin number 13 and 7. This is pin number 7. 7 will be connected to pin number 13. 9, 10, 11, 12, 13. This is pin number 13. We will take first output from pin number 1. To monitor output, I will use LEDs. Here I connected CD4049 LED cathode grounded. At anode I will connect 1 kilo ohm resistor. First output from pin number 1. We will name it phase A. From pin number 15, we will take output and we will connect to CD4049 IC. We will connect to pin number 3 and we will take output from pin number 2. It is phase B. When we are connecting 4049, its pin number 1 is VDD. Pin 8 grounded. CD4049 pin number 1 positive VDD supply pin. Pin 8 ground or VSS. So I connected pin number 1 to positive supply. Pin number 15 of this IC will be connected to pin number 3, that is input, and we will take output from pin number 2. Next output from pin number 14, 15 and this is 16, so here is pin number 14. We will jumper pin number 14 to pin number 11. Then we will connect same pin number 14 to inverter IC This is part of CD4049. We will connect to pin number 5 and we will take output from pin number 4. 5 input, 4 output. Pin number 14 and 11 will be jumpered together. 9, 10, 11. It will be connected to 14. I made jumper 14 to 11 and then this point will reach to pin number 5. 5 will be connected to pin number 11 and 14 common point. Pin number 4 of this IC will reach to pin number 3 of this IC. Pin 3, pin 4, pin 9. 3, 4 and 9. Pin number 4 of CD4049 will reach to pin number 3 here, and we will jumper 3 and 4 together, and we will jumper 3, 4 to pin number 9. To test it, I will apply PWM signal. This is PWM output signal from this XY PWM generator module. We can take any signal, any clock signal. We will apply power, positive voltage. This is ground. Now I will power it up and then we will connect to oscilloscope to see its phase shift. If you are enjoying this demonstration, hit the like button. I will connect 12 volt power supply, negative to the negative rail and positive, 12 volt to the positive rail. I injected 1 Hz frequency. Now we can see the phase sequence. If we want to split these signals into 6 signals, phase A high, phase A low, B high, B low, C high, C low, we will use more inverters. This signal will be injected to inverter. That signal will be inverted. One high, second signal will low. Input frequency at clock pin will be divided by 6. Let's suppose if I inject 120 Hz at input, 120 Hz. Let's see frequency at output line. Common. This phase 20 Hz. 20 Hz. 20 Hz. When I will need 400 Hz, 400 multiply with 6, I will need 2400 Hz at input. Yes, input frequency is 2400 Hz. This pin 400 Hz. Here 400. Here 400. If I want to set it 60 Hz, that time 60 multiply with 6, 360 Hz at input. It will create 60 Hz. If I set 300 Hz, 300 divided by 6, 50 Hz. Now let's see phase sequence on oscilloscope. We have 3 outputs, first, second, third. First phase is rising up, then after its center point, approximately 120 degree, the next phase is starting. When it will reach to 120 degree, this phase will start. So 3 phases have 120-degree phase difference. This time it is digital pulse. If you want to split it into 6 signals, then we will pass these signals inverter IC CD4049. Depending on input pulse, we will receive output. Input frequency divided by 6, that is output frequency of each phase. I am injecting 1200 Hz, 1.2 kilohertz. Output frequency here is 200 Hz at each phase. In upcoming session, I will create an E555 timer. We will inject that signal to pin number 6 of this IC. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.